All right, welcome back. And today we are going to do a question called running median. So here's the question. You are given a stream of numbers. Compute the median for each new element. Given 2, 1, 4, 7, 2, 0, 5. The algorithm should output 2, 1.5 because 2 plus 1 divided by 2 is 1.5. Oh, in case you don't know, a median, if it's an odd number, then it's just the middle of your array. Like if it's 1, 2, 3, if your array is 1, 2, 3, then a median is 2. But if there's an even amount number like 1, 2, 3, 4, then the median is between 2 and 3. So you just add those 2 and divide by 2. Yeah, so that would be the median. Anyways, and then if it's 3 elements, so 1, 2, 4, then the median is 2. If it's all these 4, then it should be 3 because 1, 2, 4, 7, it's in between 2 and 4, and what's in between 2 and 4, it's 3. And then yeah, that's pretty much. So that's what the running median will be. To make this problem easier, you should think about it in terms of like a data structure that you have, because this question is essentially, it's a pretty popular question, but they usually word it differently. They say like build like a class where you have 2 operations, add number and get median. So then in essence, this question, you're just adding and then getting median immediately, adding and then getting median immediately, adding and then get median immediately. All right, so how do we do this? Let's think about the brute force way first. Let's go to our drawing board. So the most simple way is what we're gonna do is we're gonna keep an array, for example, like this array. And then actually, let me write the numbers down. So it's 2, 1, 4, 7. So this is your input, and then you get it one by one. So what we want to do for this problem, let's say we defined running median. What you want to do is you want to add number, and then you just want to print median. Print median. That's it. So how are you going to find a median, and how are you going to add? Okay. So that's basically what you want to do. It's these 2 things. So let's do the easy way. Let's do the naive way. Let's call it purple. So the naive way would be we have an array. Cool. And then every time we get a value, actually I'll just open up the bracket so it's easier. Every time we get a value, we put it here. So add is as simple as just adding it to the array, right? Adding. So add would be O of 1. This will be the time complexity. Perfect. What about find median? How do you do that? Well, because it's not sorted, you're going to have to sort this first and then find a median. And median is pretty easy. It's just length divided by 2. You take that index, right? So yeah, and then that's it. You just do length. But sort is n log n. So print median will be O of n log n. So then the total complexity would be, because you have to do it n times, it would be n times n log n. So that's pretty inefficient, right? There's a lot of like things you have to do. It's n squared log n. Actually, let me write it down, which is not very efficient. Yeah. So is there a better way of doing it? Let's think of method 1. Call it sorted array. It's actually not the best method, but I'll just say it anyways. So in this method, what you want to do is you want to keep your array sorted. So almost the same thing as last time, but this time you always have sorted array, right? So what you're going to do is you have this array. Every time you get a number, you get 2, and then you get 1, then you're going to do insertion sort. So you'll put it here. So that means you have to move the array back. 4, you moved it here. 7, you move it here. 2, you do insertion sort, put it in here. You have to move 4 and 7 over here, right? So what is the time complexity for this? Well, to add number, to find where to insert, that's log of n, because the reason you could do a binary search, and the reason why you could do a binary search, because it's a sorted array. But when you add the number, it still has to be O of n. And the reason why is because once you add it, you have to shift all of these guys that way. So by shifting, it's O of n anyways. So O of n. And then print median would be O of 1, because you could just calculate the length, divide by 2, and then that would be it. So then total, this would be O of n squared, because you have to do it n times. Not bad. So time complexity, O of n squared. Space complexity, O of n. All right, not bad, not bad. Okay, cool. So is there even a better way of doing it? Oh yes, there is. And then the answer is actually creating 2 heaps. Now I'm not going to explain what 2 heaps, I'm not going to explain what heap is, because we already explained that in Tech Interview Pro, and you should know what that is already. So 2 heap. How are we going to use 2 heaps? So I'm going to draw them, like this. Let's just say this is 2 heap. This is like a max heap, and this is a min heap. Okay. So the way to do this is actually pretty cunning. So the thing is, you want to add the number, and then you want to add it into either your min heap or max heap. And then for every time you add a number, you actually also rebalance your heaps. So that's the thing. You add a number, you rebalance the heaps, and then you print median, right? And printing median would be easy, and I'll tell you how. So the key here is to have half of your values here and half of your values here, so that the median is this value or the average of these 2 values. And when I'm doing this circle, it means it's the min of this heap and the max of that heap. So where do we decide where to put? Well, if ever the numbers are bigger than the median, you want to put it in the mean heap. Okay, so let me write this down. Here it would be bigger than median, and then here it would be smaller than median. Sorry for my my penmanship. Okay, so how would that work? Okay, so for 2, we're gonna add 2, and then we see that there's nothing in our heaps, then we just add it here. Boop. Right? And then 1, we're gonna add it here. And now the median is 1.5, right? So, and then 4, we're gonna add 4. Is that bigger or smaller than the median? It's bigger, right? And then we're gonna rebalance this. So we always want this guy to be either 1 more, like we either want it to be perfectly equal or more, or like 1 more here, because we want to have the median on this side. Or should we do it on this side? It actually doesn't matter. All right, let's just say we want it on this side. So now the median is 2, because there's 1 extra element here. And then we get 7, but now the size of this is 3. Actually, wait, the size of this heap is 3 and this is 1. So we have to rebalance. So how do you rebalance? You pop this guy and then you insert it here, right? So now 2 is here and then 1 is here, just so that it's more easy. Actually, I'm gonna put like 2 and 1, but you have to understand that I'm gonna put all the elements here, but this doesn't really mean anything. Like I could put the max here if I want, because it's just more simple. Okay, so then this is what happens. Now I have 1, 2, 4, 7, and then now the median would be the average of 4 and 2, which is 3.5. I'm not gonna write it here anymore because I think you understand the reasoning. Okay, and then now I want to put 2. Okay, so 2, is it okay, I'll still write it. Is it bigger or smaller than the median? It is smaller. So then 2 would be popped into here. But now there's a debalance. There's 3 elements here and 2 elements here, and we want this guy to be the one that has either 1 more or equal. So we're gonna rebalance. We're gonna pop the max here, which is 2, and then we'll insert it here. Okay, and then now we have 0. Oh, so what's the median now? The median now is 4 because it's this guy. And then now we have 0. Is 0 smaller or bigger than the median? It's smaller, so we put it here. And then now the median is, let's see, 2, 4. Oh wait, it's 2 actually, because 2 plus 2 divided by 2 is 2. Yeah, okay, that's good. And then last but not least, we have 5. Is 5 bigger or smaller than the median? It's bigger, so we're gonna pop it in here. And then since the size is the same, or actually the size is one more than the left heap, it's bigger. There's one more element, so that's fine. We don't need to rebalance. And then the min here is number 2. So there we go. This becomes 2, it's still 2, and then that would be the median. So as you change the median, you keep printing them. I actually should have drawn an array, but that's pretty much how you do it. So what's the time complexity of that? Well, to add the number, what you have to do is, well, actually, let me talk about heaps. So heaps, when you insert into a heap, it's log of n. When you pop, it's also log of n, because you kind of have to rebalance, right? Let me double check. Let me show you an article. Heap Wikipedia CS time complexity. As you can see here, we have a heap. I'm not sure what this is, but let's see. Actually, it might be easier. I think usually we have a binary heap. Yeah, this is what we usually implement it with. So binary heap, let's see if they have a time complexity. Yeah, so to time complexity, finding minimum is O of 1. Deleting the minimum, which is the same as popping, is log of n. Inserting is also log of n. So pretty good. So pop and insert is log of n. So what do you do when you, in every operation? So you're gonna have to insert once into one of the heaps. And then if you have to rebalance, you're gonna have to pop and then reinsert, right? All right, yeah, so all these operations are log of n. So in the end, doing this rebalance and stuff, it's log of n. So that means we take log of n, and then print median, that's only O of 1. And then because we have to do it multiple times, all right, let me just circle them in yellow. Because we have to do it multiple times, we have to do n times. So then the time complexity becomes n, because we have to do it n times, log of n, right? Because print median is O of 1, and then add number is log of n. And then the space would be, let's see, we need 2 heaps, and then the max that you can have in them is the amount of numbers, so O of n. So it's linear. All right, so that's pretty much it. So let's start coding it. So running median, we are going to do the same thing as before when we drew it. So first we want to have a min heap, and then we want a max heap. And in Python heap, we use the heap queue. So we have to use this. And how it works is that you just give it an array, and you heap queue push, and then you have various function, and then they'll just keep the array ordered in a way that you can use it as a heap. Because you could actually implement a heap just using an array. You just have to do some fancy jumping, but more on that in Tech Interview Pro. All right, so you have 2 heaps, and then to make it easier, what we're gonna do is we're just gonna have negative in the max heap. We're just gonna put negative numbers, and the reason why is because heap queue is only a min heap kind of operation, but to make a max heap, we're just gonna subtract it. Well, I mean, we're just gonna turn it negative, so then the bigger number becomes the smaller number because we put negative in them. Anyways, okay. So that's what we're gonna do, and then what we want to do is for every number we want to add. Remember, like, we want to add number. We're not going to implement this yet, so we're just going to put triple dot, and then we want to rebalance our heaps. Okay, dot dot dot, and then we also want to print median. And then actually, let me just write the arguments here. So rebalancing, I just need the 2 heaps. Add, I need the number, and then also the 2 heaps. And now what we have to do is we just have to implement these 3 functions, and then we should be done. Okay, so let's implement add. Okay, number, min heap, max heap. All right, and then we also have to implement print median. let's implement print median because it's actually the easiest one to implement, right? And the reason why it's the easiest to implement is because it's just the O of one thing. So what we're gonna do is we're gonna check if the length are equal or not. So if they're not equal, then we want to just print the element that is more, which is on the min heap. So we're just gonna return min heap 0. So the property of a heap is that the first element is the minimum. Okay, cool. And then if the length of min heap is smaller than length of max heap. So what we're gonna do here is we don't care which side. It could be on the left side, it could be on the right side where it has the min or max. So we're gonna do both cases. So here we're gonna return the negative of max heap. All right. And then, or else what we want to do is we're just gonna take the first element of the min heap and the first element of the max heap, and then we'll just average them. So that's when there's an even number of elements in our array. Okay. So the min root would be min heap 0. This is just to make it a little bit more easy to understand. And then max heap 0. All right. And then what we're gonna do is we're just gonna return the average of both. All right. And then now what we want to do is we want to implement add. So implementing add shouldn't be that hard. You just have to put it in the right heap, and then you're gonna have to balance it out a little bit. Okay. So we're gonna do, let's see. So the first case is if we want to make sure that there are some heaps, because like in general, if there are no elements in the heap, it's actually pretty easy. You just put it to the one you want. Okay, so for example, if min heap plus length of max heap is 1, then what you want to do is you just want to push it into the max heap. Heap q, heap push, max heap num, and then that's it. Okay, and then we want to get the median. We haven't implemented that yet. Oh, actually we did. It's right here. It should be get median right here. Okay, we haven't printed yet. Okay, and then we're gonna return. Let's see. We hit push, return here. The median. We're gonna get median. Okay, min heap, max heap. All right, and then now, if the number is bigger than median, remember we want to push it to the min heap. If it's smaller than the median, we want to push it in the max heap. Heap q dot heap push min heap num. All right, and then else we're gonna do the same thing, but don't forget we gotta subtract. We gotta negative it. Okay, heap push on the max heap, and we're gonna negative that. Cool. Yeah, so that's how you add it, right? You just put it in the right place, and then we gotta rebalance, right? Remember what we did before. And then for rebalancing, we want to check which one's the smaller one. Okay, max heap. Oh yeah. Okay, +1. So it's always okay if there's only one extra, because you know, if you have an odd number of elements, of course one of the heap is going to be bigger. But oh, we're almost out of time. Okay, so I'm going to code it a little bit faster now. So essentially rebalancing, that's what we have to do. Like looking at either one of them, if one of them has 2 more elements, we're going to rebalance by popping the min or the max and put it on the other side. All right, let's do this. And then last, for print median, we're just gonna print get median. So it's pretty simple. Okay, let's see if this works. There might be some, oh no, actually that's totally fine. Yeah, so here we have 2147205, and we're supposed to get 2, 1.5, 2, 3.0, 2, 2.0. Well, it's also 2 and 2. The reason why there are point zeros is because we're gonna like average them. So that means sometimes it's like a float number. So anyway, so yeah, so we got the answer, and yeah, so that's pretty much how you do it. So hope you learned a lot, and thanks for watching. See you in the next one.